So let's start. We want to look at the basic electrical quantities. And these are the outcomes of what we expect by the end of the lesson. We want to state the basic SI units. We also want to recognize the derived SI units. Then we'll also look at we will also state the various units of electrical quantities, and then finally perform the symbol calculations. So to start off with, we want to look at the basic SI unit. So if I can ask maybe from the definition given, who can give us a summary or a brief of what the SI unit is? Class? Hello, class? Crispus?
The SI units are a set of units that are used for various measurements in engineering and science.
Yeah, correctly. Thank you. So from the definition, you can see these are standardized international units which we use for measurements of electrical quantities. So first of all, we have the derived. We have the basic, then we have the derived. And these derived ones are determined from the basic units. So we derive the derived units from the basic units. So you can see from the definition there. Let's move forward to see what are these quantities. So from the table, you can be able to see we have length. Length is measured in a standardized unit called meter, and it's denoted by M. We have mass as kilogram, kg. Someone to mute, Isaac. Okay, we also have time, which is given as second. We have electric current, thermodynamic, temperature given as Kelvin, denoted by K. We also have luminous intensity, which is candela. Then also we have the amount of substance. The amount of substance is also given by mole. So next, we want to look at the derived SI units. We said these are derived from the basic units. So we can say derived SI units, this is a combination of basic units, and there are many of them. For example, we have velocity that is given us as what? Class? Which two basic units that give us velocity when we combine them? We have the velocity. Velocity is the derived SI unit. Which two basic units that are combined to give us velocity?
I think we have length and time.
Yeah, we have length. Length is given as meters.
Okay.
And we also have time because velocity is given as meter per second, or rather length or distance divided by time. That's where we get the meter from and the time from. We also have acceleration. Acceleration is also given as meter per second squared. So this SI unit may be as large or as small with the given prefixes which I've indicated in the table below. So like when we speak of mega, mega means we have to multiply by 1,000. Mega means 1 million. So that is 10 raised to power 6. We also have kilo. Kilo, that means 1,000. Milli, that means now we have to divide by 1,000. We also have micro, divide by 100,000. We have nano, which is given us 100 million, or rather 1,000 million. So we divide the given basic unit by 1,000 million, or rather 10 raised to power minus 9. Okay, so from the prefixes, let's look at the electrical quantities now in terms of charge. So we have charge is given us. How do we get charge, class? Or rather, what is the unit of charge? Class, are we together?
The unit of charge is the coulomb.
Yeah.
And 1 coulomb is 1 ampere second.
Yeah, correctly. Isaac, you wanted to try?
It has been answered. Thank you.
Okay, thank you. So we can also see how we define the quantity of electricity. That is the coulomb. The coulomb is defined as the quantity of electricity which flows past a given point in an electric circuit when a current of 1 ampere is maintained for 1 second. So that is what we call charge. We also have another quantity. Okay, charge. Isaac, can you mute, please? Thank you. So let's look at an example on how we can calculate the quantity or the units of charge. For instance, we have a problem here where we are told if a current of 5 ampere flows for 2 minutes, find the quantity of electricity transferred. So the calculation is given us the quantity of electricity, which is denoted by Q, is given as current times the time. And the time, remember, must be, we said, in seconds. And the current, the unit of current is amperes. So it's given us 5 times. If we have 2 minutes, that means we have how many seconds? 1 minute is equivalent to
60 seconds.
60 seconds. So 2 minutes, that means we have 120 seconds. Exactly. So our quantity of electricity is 5, which is the current times the time, which is in seconds, that is 120, giving us 600 coulombs. Well, next we have another quantity, which is the force. And the force is given us, or is the unit of force is the Newton, given as the capital, where 1 Newton is 1 kilogram meter per second squared. The Newton is defined as the force which, when applied to a mass of 1 kilogram, gives it an acceleration of 1 meter per second squared. So the force is given as newtons. It's given in newtons, actually. The newtons is the unit of the force. So we can also see how the force can be calculated. Force is given as the mass times acceleration. And remember, force is a derived electrical quantity of a combination of mass times acceleration. So for instance, if you have a mass of 5,000 grams accelerated at a speed of 2 meters per second squared, then you can be able to find a force, and that force is given as mass times acceleration. And the mass, remember, it's in grams. We have to change it to kilograms. So 5 kg times 2 meters per second squared, it will give you 10 kilograms meter per second squared. And 10 kilograms meter per second squared is equivalent to 10 newtons. So we also have work, and we all know work, the unit of work is joules. So we can say the unit of work or energy is the joule, where 1 joule is 1 newton meter. The joule is also defined as the work done or the energy transferred when a force of 1 newton is exerted through a distance of 1 meter in a direction of the force. So work done on a body in joules, that is work, can be given as force times what? Class times distance. Distance can be given, is denoted as small s. So work is given as force times distance.
Distance.
Yeah. So, and the energy, what is the energy? Energy is the same as the capacity of doing work. So force, or rather work, and the energy is the same thing. So that is what we have for today. And I've already enabled the slides on the LMS. I'm sending you the link where you can be able to open them and download them. You can also be able to see the recordings. I've also indicated a video on that. I've inserted a video on that slides, which you can be able to see the derived units, many of the other derived units. So that's what we have for today, and I want to thank you, class, for your cooperation. Let's meet tomorrow for another class. Unless there is a question, then we can be able to end there. Any question? Any question?
No question.
Class? Isaac, class rep?
I have no question. I've understood the lesson.
The lesson is okay to you?
Yes.
Chirono, are you okay?
I'm okay, sir. Thank you and have a good afternoon.
Okay, thank you for your cooperation, Crispus, Anton, Kinka, Isaac, and Chirono. I want to thank you for your time. Let's meet for another lesson tomorrow. Thank you.
Okay, sir.